1998 for Asian Games. They constructed all of these very huge structures. Who designed it? Structural engineers. So no matter who is playing in the Olympic Games, who is not, structural engineers are always playing because they need to design it, right? So this is all designed by structural engineers, all the arenas, all the domes, everything done by them. And just like you know, people like you, nothing, they didn't come from Mars or some other planet. They were just structural engineers, studied just like you, and then start designing these things. Nuclear power plants, as I mentioned. Whatever you can think of, it is done by engineers, right? So basically the purpose of this master's course will be to be able, for you to be able to design these things, right? If you are interested. Transmission towers, silos, grain, food, you just talk about anything, cement plants, whatever is being done, it's ultimately coming back to structural engineering. Now this is an interesting book, The Tower and the Bridge, The New Art of Structural Engineering. Please note it down and find it on the internet and read it. Or if you like to read on your mobile or something, get this book. This is a must read for structural engineers. Beautifully written book about the designers, about the designs, about tall buildings, about bridges. By the way, anybody knows where is this bridge? It is in Switzerland. It's one of the most beautiful bridges. It's designed by an engineer called Robert Mellard. Of course, you know, one of the things the architects study, the difference between structural engineers or engineers and architects is, anybody from architecture background? They study, out of 5 years, they study 4 years history of architecture. They know the names of all big architects. If you talk to an architecture student and show him a building, he will know who designed it. And he will know what the building's form, and because they study. And they study about the people who designed it, they study what they learn from the previous work. Engineers never know anything like this class. They don't know anything. They have never seen or read about engineers or the designers. If I ask you, do you know any big structural engineer's name? Do you know? We should know. The one that we want to be, or we want to, you know, some kind of Dr. Fazlur Rahman Khan. Okay, you know him because he was from Bangladesh later, yeah. Yes, the big name, Afar Khan, right? But the thing is, he knows him for a different reason, not as a structure. But my point is that we need to know people who did great things so that we can learn and we can also do something like that. And that is what I'm trying to do in this first lecture, to expose you to big things. And this book is about that. It's not about technical, no equation, no nothing. It's a nice reading book. You can read about structures and read about engineers who designed them and how it evolved. So look at that, the new art of structural engineering. Because structural engineering is not just calculation, it's an art. It's not even a science, it's an art. Art is the highest level of something. When something becomes really great, it becomes an art. So structural engineering, so you have structural engineers, then we have structural designers, and then you have structural artists on top of that. When you become really great, you become a structural artist. If you design something good, you are a structural designer. If you just do the calculation, you are a structural engineer. So I don't know which one you want to be, structural engineer, structural designer, or structural artist, right? Structural engineering is big field, really big, really big if you think about it. Because in structural engineering we do a lot of activities. Develop the concept, do the analysis, do the design, do the detailing and many things. The structures that we deal with may be buildings, bridges, trusses, shells, towers. I showed you many kinds of structures. There are many design codes to follow, American, British, European, Japanese. You may be working on some other country or another project. So you cannot just only learn one code anymore, because projects are now international. So you may be, you may learn from here, but you may be, working in a project in Dubai or in Middle East. So Thai code will not be useful there, right? So you have to learn to understand other codes. Material, you may be concrete designer, steel designer, timber designer, totally different, right? Model, you could have many modeling, we will talk about that. So analysis, many types of analysis, equation, so many things. So this is really a big field. So ultimately, you cannot do everything. You will say, okay, I'm only going to do the analysis of buildings using American code in concrete. So you're going to be very narrow in what you do. And that is not going to be so good. So you need to have, so this course especially is going to be very, very, I would say, first of all, you have to forget everything that you learned in undergraduate. It was all wrong. You have to start again. So you have to forget about the concrete that you learned in your undergraduate. It was not right. Okay? So we have to learn it again in a different way, because we want to learn in such a way that we can do this all without relying on a simple equation or something. So we will talk more about that. So if you are going to be a structural designer, structural engineer, you can be doing any one of these things. So this is the owner of the company that you might be working on, and he may be doing client dealing, coordination, many things, and then he has structural engineers or structural designers under that, and they may be doing any of those tasks. So as you become more senior, you become doing more of these things, and finally you can be the owner, or you can be the owner the first day. Startup. Who attended the orientation? Yeah. So I talked about startups on that day and the opportunity for innovation. So you can even do innovation in startups right away. Now this is a very interesting topic, which I'm going to give you the first assignment later. Computer application in structural engineering. Because, as you know very well, without computers, you can't really do much, right? Of course, in my age, of my time, we didn't have computers. Actually, I had a computer, that's a different story some other time. But now we rely on computers a lot, too much, and that's causing problems also. So we will come back and talk about this application of computers in more details later. If you look at a building, a simple building, you will find that there are many parts of the building. You have a wall, you have floor slab resting on soil, you have columns, you have foundations, you have staircases, you have many types of structural floor system, joists, column, beam, walls, many things. So we need to learn to design all of these, right? We should know how to design a column, a slab, or a footing, or a stair, or shear wall, and something like that. So but all of them are made from concrete, in this case, which means we need to understand concrete, reinforced concrete. And that's what this course is about, understanding the behavior of reinforced concrete, so that you can design anything and everything. Some other examples of various reinforced concrete building elements: column capitals, block panels, flat slab, flat plate, many things here. So we will go step by step into each one. So you should be able to design these parts of the. Right now, if I ask you to design, forget about the tall building. If I ask you to design a flat slab, can you? Anyone? Raise hand. You can? How? Okay, good. So you use that, you teach that? You did it? Okay. Anybody else knows about the strip method? Although that's not right, but okay. But now we'll say the strip method is interesting. So what is so advanced in this class? What is going to be advanced? We call it advanced concrete design, right? So as I mentioned, that everything that you learned about reinforced concrete in undergraduate, you have to forget about that. Unfortunately, that knowledge will not be so useful. It will be, but not so useful. First, main thing is that we have to go before and beyond the code. That is the key difference. We are not going to learn any of the building codes, Thai code, or ACI code, British code, any code, we will try to understand what is behind these codes, what is the common understanding, so that we can follow any code. We will challenge the code